Okay, so this is video 5. This is the last one for 10.1. This is where we're going to put all the information that we just did into one problem. So I've given you the example of how to um, do the work. We'll try and work as much as we can with the calculator so you can work with it that way. But we're looking at, this is, I didn't title it, sorry I forgot. This is General Motors health question, okay? So, in an effort to reduce healthcare costs, General Motors (GM) sponsored a study to help employees stop smoking. In the study, half of the subjects were randomly selected to receive up to $750 for quitting smoking for a year, while the other group were simply encouraged to use traditional methods to stop smoking. None of the 878 volunteers knew that there was a financial incentive when they first signed up. At the end of 1 year, 15% of those in the financial group had quit smoking, while only 5% in the traditional group had quit smoking. Then, I gave away too much. Do the results of the study give convincing evidence that financial incentive helps people quit smoking? So what I did is I already put together the hypothesis and the alternative hypothesis, okay? And I know this is kind of fuzzy to read, but it says P hat F, meaning the financial group, minus P hat T, meaning the traditional group, is equal to 0. And then P hat of F minus P hat of FT is greater than 0. The reason why I did it is you could think of it like this, because they're wanting to know, is that true? Okay, does the financial incite more incentive for people to quit smoking? Okay. Um, so if you do this way, you need to make sure that your null hypothesis is equal to each other. Okay. Um, I I haven't seen any way that one way is better or the other. It just depends on what you're looking at, who your professor is. Okay. All right. So I did real quick the conditions already. Um, just so that we could have that because you guys are pretty sick of those. So I did independent, each worker is independent of each other. Random, it was stated. Our 10% condition, 878, is less than or equal to 10% of all GM workers. The population size for the financial group was 439 because our whole size, or the samples group, was 878 people volunteered, and then they took half of those and put them in the financial group, and they put the other half into the um, into the traditional group. Sorry. So then I did the large numbers, boom, 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 and they all checked out wonderfully. Weird how that worked out for us, right? Okay, so we need to do our pooled, our combination. So the success, I'm going to round this up to 66. And I'm going to, come over to here and round this one up to 22. And then this one's pretty easy, but I'm still going to put each group so that I can keep everything up to it. All right. So then I know that using my calculator, I get that as my pooled combined. Okay. So once I have that, I need to work into my test statistic. Okay. And my test statistic says to take the probability of F minus the probability of my traditional group, subtract that from 0, divide that by the square root of 102, and then its opposite is 0.8998, and there's 439 plus 0.102, 0.8998, 439, Okay, and so then that gives me 493. All right, so now once I have that, I want to go with my normal CDF because it's greater than, right? My lower bound is going to be 4.93. My upper bound is going to be the 1E99. My mean is 0. My standard deviation is 1. And so then we get 4.11 times 10 to the negative 7th. What does that mean for us? Well, 1, 2, 3, 6, 4, 1, 1. Basically 0. Okay, so then what we would do is we would come in and say, oh, excuse me, my significance level is 0.05. So why did I choose 0.05? Well, it didn't tell me what else to use, so I got to use this. Okay, so then I'd come in and say, 2, 3, 4, 5, 6. 411 is less than 0.05, which means we reject the null hypothesis. Okay, so then we would say there is significant evidence that offering a financial reward influenced influenza the workers to quit smoking. Okay, so I'm going to pause it real quick and then set my calculator up to show you how I can do it just using my calculator. Okay, so I got my calculator. I had to go dig it out and find it real quick. What we're going to do is we're going to hit our stat. We're going to bring up the test, okay, and then we're going to move over to tests. We're doing a 2-prop z-test, okay, so a 2-prop z-test. All right, I put in 66 for the financial group. I put 439 for its sample size. 22 is the successes in our traditional group, and move down 439. I want greater than, so I'm going to calculate. So I guess on the two, I need to go back to here. I'd come into here and say, remember the variables so I don't screw it up. So I'd go x1 is equal to 66, n1 is 439, x2 is 22, n2 is 439. Okay, I already have the greater than because that's in my null hypothesis, or my alternative hypothesis, excuse me. So then I can calculate it. One thing that was given to me as a teacher's tip is to make sure that you state that from this you would get a z score is equal to 4.94, which is close to our 4.93. Our p-value is equal to 0.123456382. All right. Now, the reason why we're off just a little bit here It's still basically 0, but remember we are terminating our decimal up here in our combined. We're terminating at a 0.1002, and we're calculating everything else way past that. So our p-value is going to be a little bit different. So make sure that you write that you did, I did my calc. I used my 2-prop z-test. Here's the data I put in. I got a z-score of 4.94, which is close to ours of 4.93. And then everything else is pretty close to that, okay? And then, of course, we would still be failing, or we would reject null hypothesis, okay? So our homework is page 631. This one it seems long, but they're pretty quick. I did it last night. So just like always, if you have questions, make sure you're talking to me, guys. Okay, wash your hands. Have a good day.